Good morning. So today in Algebra 2 CP, what we're looking at is rational expressions, equations, and we're going to solve them. We're going to start out with a little bit of review here. Find the least common multiple for the following groups of terms. So if I take x squared minus x and I factor it, that would give me an x times x minus 1. Okay, that would be all the factors in that one. And if I took a 5 and an x minus 1, and I took, the formula that I'm going to look at is all common factors times all non-common or unique. Non-common factors, okay, the unique ones. So when I look at these, I see I have a common factor of x minus 1, so that'll be x minus 1 that's common, and then I have an x and a 5 that are uncommon. So my least common multiple would be 5x times x minus 1. Okay, 3x squared, 5x and 2. If you took the 3 and the x, the 5 and the x and the 2, I'd have a common factor of x. That'd be my common, and that'd take care of this one and this one. And then I have an x that's not common, a 3, a 5, and a 2. So that would give me 10. 5 times 2 is 10, times 3 is 30, times x, or 30x squared. And that would be my least common multiple for those three terms. All right, factoring this, I see I got a common x squared. And if I take those out, I'll have an x plus 3 left over. And on this one, I have to use my eyeglasses. Split the x's, factors of 35, sum of negative 12 would give me a negative 7, negative 5, or x minus 7 times x minus 5. All right. Well, we're looking at solving rational expression equations, rational equations. To solve a rational or equation containing rational expressions, you first multiply each side by the least common denominator of the rational expressions. Doing this, however, can introduce extraneous solutions. So what is an extraneous solution? An extraneous solution is solutions that, as we've seen before, that are formed by patterns by working the problem out correctly, but when we check it, it doesn't work. So there's an extraneous solution. You always have to check your work. We'll start with this first equation. All right, so first thing I want to look at is my denominators, and to make sure that they're in factored form. Well, the right side is definitely not in factored form, and if I factored that out, that would be an x plus 3, x minus 3. Okay, and as I look at what would my least common multiple be, there would be a common x plus 3 and a common x minus 3. So my LCM is x plus 3, x minus 3. Now, if I followed that formula that said we multiply both sides by by the least common multiple, so what that would give me would be an x plus 3, x minus 3, all the way across. X plus 3, x minus 3, and x plus 3, x minus 3. And then we'll cancel out my like terms. Now, note the equation. All right, we already factored this down. The plus 3's would cancel and the minus 3's would cancel, and I'm left on the right side with a 2. Okay, On the left side, I have an x minus 3 and an x minus 3, and that leaves me an x times x plus 3. And on the second term, I see I got a plus 3 and a plus 3, leaving an x and an x minus 3, so this would be plus x times x minus 3. Okay, now if I distribute those guys, then that's going to give me an x squared plus 3x, and this would be plus x squared minus 3x equals 2. All right, my plus 3x and my minus 3x are going to cancel, and when I add 2x squareds together, that will give me 2x squared equals 2. When you divide out that 2 to get x squared by itself, you're going to get x squared is 1. And then when I take the square root and the square root, don't forget the plus and the minus, and we would get x equals plus or minus 1. Now, what we want to do to check to find out if we've got, I'm going to cancel out all of those there so I can see down in here, and I'm looking at the denominators, and if I plug a 1 in there, does it go to a 0? And it does not. If I plug a negative 1 in there, does the green marks go to a 0? And they do not. So I have two solid answers here. Those are both correct. X equals 1 and negative 1 to put two possible solutions, or two solutions. All right? So on this one, we'll go back to the black again. And on this one, I'm going to have to factor this side, which would be x plus 2, x plus 1, and cancel that out. And then we've got the plus 2 and the plus 1 here. So again, my LC D is x plus 2, x plus 1, and that takes care of them all. There are no non-common. So we'll multiply by x plus 2, x plus 1, and x plus 2, x plus 1, and x plus 2, x plus 1, and cancel the like terms. Well, cancel, 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 cancel. Everything cancels, and it leaves me with just on top x minus 1. I'm just going to put x minus 1. I don't need to put it over 1. Plus, over here I got the x plus 2's canceling. Again, a 1 in the denominator. So I have 2x times x plus 1 equals, and over here the x plus 1 and the x plus 1 cancel. So I have an x minus 1 and an x plus 2. Okay, distribute your 2x here, and I'm going to get 2x squared plus 2x, and then plus the x minus 1 from the first term equals, I got to FOIL this one. Okay, that's going to give me x squared minus x plus 2x, or plus x, okay, because the minus x and the plus 2x combine to give me plus 1x, and then minus 2. All right. So, now if we combine like terms, there's x's there, so this would give me a 2x squared. Positive x, positive 2x would be plus 3x, and then there's the minus 1 equals x squared plus x minus 2. Now if I subtract x squared, subtract x squared, subtract x, and add 2, I will get a 0 on the right side. Well, that'll give me an x squared and plus 2x, and plus 2 plus minus 1 would be plus 1, which is going to give me an x plus 1 times x plus 1. Okay? If I set that equal to 0, I could use my zero product property, and I would get x plus 1 equals 0 twice, which gives me x equals negative 1. Now, if I put negative 1 up here in the first term, that would give me negative 1 squared, or 1, minus 3 would be 2, and plus 2 would be 4. So that doesn't go to 0. We're okay there. And if I get negative 1 in here, that would give me a 1. That one's okay. And the negative 1 to this one, however, causes a problem. I go to 0. And since I have a 0 in the denominator, negative 1 does not work. Well, that was the only solution because I got negative 1 here and here. It's the same solution, so this one has no real solutions. Okay. Let's take a look at problem 1b. All right, now this one, I'm going to factor above on the second term, and it looks like everything else is good. So I've got an x, split my x's, and then a plus 3 minus 1. And because these are both x plus 2's, I can disregard them. In other words, it's like if... let's go back over this. If 5 over 3 equals x over 3, we don't really care about the 3's. It's the fact that 5 equals x, or x equals 5. All right? So we're going to do the same thing with this. It'll give us an x minus 1 is equal to x plus 3, x minus 1. And if I divide by an x minus 1, I'll cancel those out, and I'll get x plus 3 equals, this is going to give me a 1. Just a solid 1, because that cancels, leaving a 1, and that cancels, leaving a 1. I have 1 over 1, which is 1. Now if you subtract the 3, it's going to give me x is negative 2. Problem. Look up here, my denominators. X plus 2, x plus 2. If x is negative 2, it's going to drive both of these to 0. So again, no real solution. All right. Now, that's going to give us enough to play with on the homework for tonight. So take a look at those, and our homework will be on in Excel marked 86A. eLearning 330 86A. Have a good day, guys. I'll talk to you on Wednesday.